first everything we're going to see tonight. We're going to solve each equation for y and evaluate the result using these 5 different inputs for x. So solving for y, we're just going to shift things over to that y equals mx plus b. It's our basic algebra stuff we're doing. In this case, I would want to add our 2x to both sides. And when we do that, we'll end up with the equation 3y equals 2x plus 9. Then we can divide both sides by 3 so that y is going to equal 2/3 x plus 3. Okay, so now I'm in y equals mx plus b format. I can then evaluate each equation for x. So when x equals -5, this will be the demo we do real quick. I just substitute that back in. So we'll end up with y equals, when x is -5 here, we'll have 2 times -5 is -10 divided by 3. Okay, plus 3, so I'm going to convert this into thirds. This will be 9/3. And then we can combine those together. So our y value is going to be -1/3. Okay, you can do this over and over and over again for all of our x values. That's all we're looking for in these first pieces. And just a heads up, my computer runs so much slower while it's recording stuff. That's okay. Okay, next type of thing you're going to see tonight is going to be each equation, put it in for solve for y, and then identify our new coefficient and constant. This is going to help us identify the slope and our y-intercept. So again, using 14 as an example, 9y is going to equal 4x plus 18. Okay, 9 divided by 9 on both sides, so y is going to equal 4 divided by 9x plus 2. So in this case, when we identify, we have our slope is 4/9, and our y-intercept, or b in this case, is 2. So then we can identify our new constant and our new coefficient. That's all we're looking for there. All right, next type of question we're going to see tonight is going to look like evaluating each equation by selecting 3 inputs. This is very similar to last night where you had to build your table and we had to choose our inputs. I want to select inputs that are going to result in integer values. What were we looking for that helped us select things that would give us integer outputs? Rochelle? We don't want to end up with a fraction, right? So what numbers for x are going to show up that help us so we're not there? Zach?
Well, I just chose numbers that could be divided by the denominator.
Excellent. So in this case, because our denominator is 4 on our slope, if we pick values of x that are multiples of 4, we're going to be able to have these integer values. So I could choose things like x equals 4, 8, or 12. Okay? So those would be 3 acceptable inputs that are going to spit out integer values. Let's test that. So given these inputs are y value, this is going to be x equals 4 right now. So we'll end up with 5 plus 1, which is 6. If I plugged in 8, it would end up being 10 plus 1, which is 11. And then when it's 12, this will end up being 15 plus 1, which is 16. And we should notice that just like the slope, when x increases by 4, y increases by 5. So we should start to see those patterns across the board. That'll help us find those integer values. So that's all that's looking for. All right, so we're going to, again, go find things in x and y intercepts to help us out. We can use these 2 points to calculate the slope. Write the equation on the lines. Okay, we're going to compare this to a calculated slope, which, if we were to calculate it, we should find out that it's, in fact, in the same form. Okay, but we'll work through this. So, again, to find our x and y-intercepts, y-intercept, we're going to plug in x equals 0. So y-intercept in this case is going to be -2. when we do our y-intercepts, just so we don't have a y equals, because that makes us think that y equals something, try to show our intercepts as an ordered pair, so 0, comma, -2. Okay? If we were to plug in y equals 0, if we plugged in y equals 0, this disappears now. And so we'll end up with -2x equals -6. So our x-intercept in this case is going to be the ordered pair 3, comma 0. Okay? So if we were to find the slope based on this, we could go ahead and say our slope equals our -2 minus 0 over 0 minus 3. Okay, or you could have it flip-flop the other way. This will give us -2 over -3, which is a positive 2/3. Now you have your slope. We have our y-intercept that we actually are solved for, so we can throw this into slope-intercept form and say that this is y equals m, which is our 2/3, x plus b, where b is -2, so -2. And then we're in slope-intercept form. Okay. As far as commenting on what we notice, we should realize that if I grab 2 points or just plugged in 2 random numbers, that slope should be the exact same, and then if you solve for b, it should get us to the same destination. Okay. Most of this review so far, feel uncomfortable with this? Next thing we're going to see is writing the equations in slope-intercept again. So now all you have to do is put it in the slope-intercept, and then we're going to identify the slope and y-intercept. Very similar to that other problem we saw where we identified the coefficient and the new constant. So number 32 is our example again. We'll end up with 4y equals 3x plus 12. When we divide both sides by 4, y is going to equal 3 over 4, x plus 3. So now we have our new slope, which is 3/4, and our y-intercept, which is 3, okay, or the coordinate point 0, comma 3. All right, now we're going to be looking at something given to us in the form of a graph. Okay, use slope-intercept form to state the equation of each line. Verify your solutions in exercise 45 and 47 using graphing calculators. Okay, so we use graphing calculators to help us out. In this case, you want to calculate the slope. So we look at our slope of this line. Our m is going to equal my rise from point to point. I'm going to go down 1, 2. So we have a -2 rise over a run of 1, 2, 3, 4, 5. Okay, or you could use your formulas and come up with the same thing. Our slope would be -2/5. It gives us this y-intercept right here at 0, 3. So the equation for this line can be written as y equals -2/5 x plus 3. Yep. So we're just going to look at graphs now based on the picture, be able to hopefully identify what the equation for that line would be. And I think we got 3 more examples of things we'll see in a minute. Okay, so here we're going to actually give you the slope and the intercepts, and then you're just going to write the equation. Everybody knows how to do that, yes? Yeah. Okay, that one's pretty straightforward. This will be y equals, my m is -2, so this will be -2x. My intercept is at 0, -3, so this will be -3, and now I have my equation. Okay, so those ones are pretty quick, straightforward type stuff. Okay, so a lot of stuff here we're dealing with is in linear equations, and we're dealing with the y equals mx plus b. So write each equation in slope-intercept form again, then use the rate or change our slope and y-intercept to graph this line. So now, again, very, very similar to what we saw earlier in the day. You just want to be able to put this into y equals mx plus b mode, so we'll end up with 2y equals x plus 4. Y is going to equal 1/2 x plus 2. Take that information and go ahead and plot our graph. We'll end up with something like a y-intercept at +2, so we are at 0, 2. Plot at least one more coordinate point. And so using our slope, we can go up 1 over 2. So that would put us at the coordinate point 2, 3, because I went up 1, so I'll add 1 to y. Over 2, we'll add 2 to the 0. That'll get us this extra point here. Now I have 2 points. I have a line. Okay. Feeling good there? And lastly, looking here, we're using our y-intercept rates of change to determine each equation. Okay, so here, everything's already done for us. And so all we need to do is plot these points. Okay, I'm in y equals mx plus b already. Y-intercept is at -1. So we got that coordinate point at 0, -1. Okay, and then our slope is 5/2, so you're going to go up 5 over 2. So if I add 2 to 0, I end up with 2. If I add 5 to -1, we get up to a +4. And so my next coordinate point is going to be up here at 2, 4. And then we end up with our graph. Okay? Any questions on what we're doing there so far? Okay, hopefully fairly reviewers tonight, and we'll be good to go.